Good morning students, welcome to Konnur's online classes. In the yesterday's class, we have discussed the basic parts of the computer. That is, what is computer, define computer. Computer is an automatic electronic device that takes an input and processes it and gives desired output. So after the definition of computer, we have seen the characteristics of computer. Yes, what are the characteristics of computer? The first one, speed, memory, accuracy, versatility, delicatness, cost effectiveness. Okay, these are all the features of computers, the characteristics of the computers. After this, we have discussed data, information, hardware, software. What is data? Yes, define data. Data is a collection of unprocessed items. Data is a collection of unprocessed items that may be a number, image, text, audio, video. Right? Next, after that, software. After that, information. What is information? Computer processed data is called as information. Just for example, in the above, RAM 5. In this one, in the information, RAM is 5. Like that. The data can't give the complete meaning, but the information give the complete meaning, useful meaning. Next one, hardware. What is hardware? The physical parts of the computer that we touch and feel. So you may ask, so what we feel after touching the computer? In some cases, if you are going to use so many hours of time, it may be heated. So there is an enormous amount of heat will be generated that you may feel. Like that, the physical existence. And software. Software means the set of programs, the set of instructions or programs that tell the computer what to do, when to do. This is all regarding software. And in the software there are two types. One is application software and another one is system software. The system software, it makes all the arrangements, it controls, maintains everything. And the application software it's just to make interface between user and the hardware and the computer software. That is what the application software. And the functional parts we have seen, it accepts the data, it stores the data, it processes the data. After that, it is going to store the data permanently and gives the output. This is all functional parts. And the block diagram of computer also we have seen, input unit, control unit, ALU unit, control unit means CU, ALU unit, arithmetic and logical unit, and another one, primary storage, primary memory, secondary memory, and output unit. What is input unit? Through input devices we are going to feed the information, we are going to feed the data, and that data is going to inputted into the CPU, central processing unit. In the part of central processing unit, depending on the task assigned, that distributes or assigns that to the part of the computer. And CU is the control unit, is the main nervous system or the commanding officer of that computer. It is going to maintain all the works and tasks to be done in a regular interval of time. So no need to wait for anything like that. That control, that is CU control unit, coordinates every part of the hardware and software part of the computer. After that, ALU, arithmetical and logical unit, if any addition, subtraction, multiplication, division operation, apart from this any basic operations, or apart from this logical OR gate, AND gate, NOT gate, XOR gate, XNOR gate, NOR gate, NAND gate. If any gate operations are come, and that it is going to be performed. This is all ALU. And the primary storage, once again in the primary storage, RAM and ROM are coming, RAM are coming, they are stored. See, for a temporarily, for a small instant of time, we need to store something. In that cases, we require memory. That memory will be satisfied. That memory will be, that part of work will be done by that RAM. That's why the cost of RAM is very high as compared to other memory, or as compared to the auxiliary memory or the secondary memory. Secondary memory is the permanent memory. So once the work is done, when the alterations is done, when the modifications are done with the file that we want to operate, after that, that will be stored in the memory of the computer. Once we save it, so it will be saved permanently. Of course, when you wish to delete, you can delete, no problem. So that will be stored permanently. And after that, the data is inputted and it is processed in the CPU. After all processing, it comes to the output device. Then that data becomes the information, and that information is given to the user. So by seeing that information, user will feel, yes, my work is done. He is going to satisfy with the work of computer. This is all regarding the block diagram of the computer. So in today's class, we are going to discuss the evolution of computer. The evolution of computer is made very far, since it is from BC to AD. Okay, it is from before Krista to after the death of Krista. The evolution was done. Today also the evolution is going on. Whatever the technology present today will not be there at tomorrow. Of course, will be there, no problem. But the evolutions today or nowadays, what we are doing, we are moving towards the nanotechnologies. What is nanotechnology? The bigger part of the computer, the bigger size of the computers are made into smaller. So that makes reduced size that made enormous size reduced of the parts of the computer. Then the computer becomes small. So today's tab is also one type of small computer. Okay, that is all regarding the evolutions. That is all regarding the computers. Now let us see the evolution. The first one is the abacus. So you might have seen or you might have heard regarding the abacus. If any students, if many of them are moving towards here and there, or even though metropolitan cities, just for example Bangalore, Kolkata, Mumbai or Bombay cities like that, there is a gaming zone. Okay, you have to pay the amount and you have to play the games like bike racing, car racing. There is a physical and virtual attachments are done. You are having steering like a car steering, but actually car is not there. But in the video game, how you are going to do the movements, that will be implemented. That is just like a 3D games. Okay, like bike, car, okay, train, like that. Or you have feel or you have seen something like that. In those gaming zones, there is one game that is abacus. That is first one. Nowadays also it is implemented in the gaming zone. See, nowadays also complex problems will be solved, or to solve the complex problem, the reference of abacus will be taken. The reference of abacus will be taken. Okay, that is the first known calculating machine for the counting. Abacus is first calculating machine for counting in the whole universe. That is the first used. You might have said, sir, previously when the milkmans come to our home, they are going to serve the milks, they are going to give the milk. How they are going to count it? They are making some arrangements like this. For first day they give like this, second day, third day, fourth day. After this they are going to make like this. So fifth. So these are the 5 number of days they have given the milk. If so 1 liter if they are giving, okay. In the next day, on the 6th day, if they given half liter, you have taken half liter, then they are going to measure like this. Once again, the measurements will be next day onwards like this. After this 5 days, 4 days, they are going to make that line, cross line, that is for 5th line. Regarding this, you might have heard or you might have seen in films. If you heard, you may know, you also know regarding ancient peoples, the peoples who are staying in the jungles. They are making some arrangements of their own. Nowadays also this one, the Egypts in the pyramids. So some symbols and the modifications and some models they are doing. That is to represent or that is to give some particular meaning regarding the what they wish to explain. Okay. The first one is, so let us come to the topic. The first one is abacus. The abacus is first calculating machine used for counting. That is the first calculating machine is for the counting. How it is done? See, there is a rod. So see, okay, that is made up of beads strung on a cords. Okay, there is a cord. On that one, some beads arrangement will be there. So by moving heaven and earth, the movements and the calculations are done. And simple arithmetic calculations are done. Addition, subtraction, and other basic operations and other basic calculations are done here. That is the first adding for the first machine counting. Cords represents positions of the decimal digits. Beads represent digits. So numbers are represented by the beads close to the crossbar, heaven and earth. So I have told in the gaming zone this abacus was implemented. The concept of that was taken and they have made some modification on that and they have implemented. Not 100% the abacus concept was implemented. Just keep in mind. You just keep in mind that is for your reference purpose. So see, this is a cord. Okay, this is one type of cord, and we will show the figure. This will be like this. Okay, there is a cord and a frame and a bar, unit points and upper beads, rod, lower beads. So after calculating, they have to move this to up. So this is heaven and this is earth. So when they come to next one, they are going to move the second rod beads, next third rod beads. Like that, the movements, the calculations they are going to do. Just for example, I told over here, their 4th day is there, and the 5th day they complete, they are going to make the cross lines. Once again, the calculations are done like that, and in some of the cases, they are going to make arrangements like that. They are going to give some stones. They are going to use stones for counting. Whenever they give the money transactions or a material transaction or the object transactions, according to that they are going to make the movement of stones. Small stones for the calculation. That is different types of references they have used. That is all regarding the abacus. And the next one is, that is Napier's bones. So regarding Napier bones, when the bones are came for the calculation, you might have heard, sir, we are the oldest person to use bone for the calculation. Why? Because you might heard regarding Mahabharata, the Mr. Shakuni. Shakuni is using bones, okay, and to play that game. For that purpose, he is going to use the bones. Okay, so like that, the bones are invented for calculation. John Napier invented that one, and the multiplication is added. So till then, addition, subtraction and other basic operations are there. The multiplication was added after the John Napier invention. A set of bones consists of 9 rods, means 9 rods are present with the bones. One of each digit represent 1 through 9. If 9 rods are present, 9 bones are present, 1 represents one number, second represents second number, third represents third number, like that 1 to 9, 9 bones are there. Constant rod for digit 0. For 0, they are represented one constant rod, fixed rod. The rod is similar to column of the multiplication and there is no movement of that 0. So this is what Napier's bone. That is the calculation. Here different rods are there and that they are going to use and make some arrangements. This is all regarding Napier's bone. And the next one is, that is the slide rule. So this slide rule is a very concept. So in this, just like a scale, all the numbers are represented. Just see, I will show in the this one. So this is slide rule. Okay, on this slide rule there is a movement, there is a bar. That is because of some marginal space, that is movement. The movement of that is done over the bar. So see, here this is a scale for reference. So and this is the starting point and this is the end point. For addition I am doing, for movement I am doing. As the movement goes on like this, the numbers of this scale will be increased. That is what they are saying. The principle is actual distance from the starting point of the rule is directly proportional to the logarithm of numbers printed on the rule. So this is a rule. The actual distance from starting point of the rule. This is a starting point and the actual distance from the starting point of the rule as goes on moving, increasing in this direction is directly proportional to the logarithm of numbers printed on this. Actually that is right. Here it starts from 1, it goes on like that up to 49, 50 centimeters it goes. Okay, 1, 2, 3, 4, 5, 6, 7, 8 like that up to the numbers. Okay, it is going to move. And William Otter invented this slide rule. William Otter. And the second point is, this is constitutes with the two sets of scales joined together with the marginal space between them. Yes, this is one scale. After this, there is another scale that is for movement of that one. And multiplication, division. Multiplication and division, both the operations are implemented on this one, that is the slide rule. Multiplication and division operations are implemented and the principle is actual distance from the starting point of the rule is directly proportional to the logarithm of numbers printed on this rule. So this is what regarding the abacus, Napier bones and the slide rule. Okay, this is all regarding this one. Now we'll discuss the remaining concepts in the next class. So today we have discussed the abacus, Napier bones, the slide rule. So how many, what are the names of evolutions of computers? That is the abacus, the Napier bones, the slide rule, adding machine Pascaline, Leibniz calculator, Jacquard's loop, Charles Babbage, the difference engine, first programmer, Lady Ada Lovelace, Collier tabulating machine. These are all evolutions of computer. On that one we have seen the abacus, Napier bones, slide rule. Remaining concept we will discuss in the next class. Till then, have a nice day. Thank you. Bye bye.